So it all started off, and I got this video recommended to me once again. It's like, yeah, they did raytracing like 10 years ago. But the solar system only works on X. Oh yeah, that's the thing. And use a GeForce 5 for them. So hmm. Bruh, bruh, bruh. Anyways, my idea was not to completely remake this, but a large uniform gravity jump map. So let's do like a typical word, but we go through a bunch of chunks. And then this idea was kind of just put on hold for a while because the school decided, oh, you know what, you have no free time, fuck you. Then eventually, my family got COVID. And yeah, there was a big tour face moment, and so I could begin work on this little thing. So I went ahead and grabbed the mono version of Godot because I needed C# for its performance over GDScript. Because I will be doing a lot of math. Oh, not necessarily math, but I will be filling up a three-dimensional texture. So you think about a normal texture, but instead of pixels, it's voxels. And this is basically used for storing the object data. So no, this is not some kind of voxel word. But the point is spatial partitioning. So basically, imagine I have the render distance of 4096 units. And so I'll be dividing up a 8192 cubed area into 16 times 16 times 16 chunks. Now there's the amount of chunks, not the size of the actual chunks. And so this would mean that the chunks would be 512 cubed in size, and that would be correct, and that would just completely defeat the purpose of this entire system. So instead, I decided not to make them uniformly scaled. Instead, I decided to scale them by the distance from the carrier. And so the furthest away chunks were this large, and they became smaller and smaller until eventually it reached the camera. And so these chunks were 32 cubed in size, and that was pretty cool. So I remember this. Anyway, these chunks are filled up with data about the objects inside of them, and then in the shader I'll be accessing this texture. Alright, so after a bit of messing around, this is what we have. Two circles. Let's go. Now, there is some kind of special alpha system here, which is more advanced than you often see in video games. Usually, you just have a constant value of, like, say, 0.5, and that's what that will look like. And it just kind of looks boring, right? And it's not really realistic at all. However, since we're ray tracing, we have the information of how much sphere the ray has essentially went through, because we know the front and the back points of the sphere that the ray passed through. Now the 0.5 is how much one unit of sphere contributes to the alpha. So here is a graph of this function. See, when you go through 1 unit of sphere, you get 0.5 alpha. When you go through 2 units of sphere, you get 0.75 alpha, and so on, until it relative approaches 1, because 1 is completely opaque, and yeah, here it's just basically 1, just running up. By the way, you might have noticed that the rendering of these two spheres takes so long that we are at 45 FPS. Like, I know the 1050 Ti is probably not the biggest 1440p gamer out there, but with drawing two circles to the screen. And it comes to my programming habits where I try to get something that functions correctly and then optimize it later. So let's just go and optimize this mess that I've created. Most of these savings come from this specific hack right here. Part of the rendering process is me uploading 16 megabytes of data into the GPU every frame, and this process alone takes 5 milliseconds. Fun fact, the GPU was only taking 2.5 milliseconds to render that image, which is not too surprising, but still. Alright, so I'm switching between traditional rendering and my ray tracer, and as you can see, the camera is now able to move around. I didn't have to change a lot in order to accomplish this. Also, the mechanic for the camera positions, that's pretty cool, it just worked first try. What about camera rotation? Right, well here's the final result, it actually works. There's some issue with transparency when the spheres are being casted twice at the same time. But screw that, I'm just gonna add a little foggy effect for when you're inside the sphere. Basically, during the ray tracing process, when the ray start is inside the sphere, it still gets the position behind it as the front position. So I'm just gonna move the front position to where the ray starts. And that means we have fog now. And also, for some reason, that just fixed the transparency issue. Okay then, fine. I'm fine with that. My first thoughts were that the Windows drivers were broken, so we tested it on Linux as well, and yeah, it still did not work. So after a bit of testing, we found out that the Intel HD doesn't really like a texture that is that tall. The maximum texture size it accepts is 2048 flat. If you put 2049, it doesn't work. So yeah, that's a thing I have to keep in mind. And I added a box to the scene so we have more than two circles. And now I'm going to turn ray tracing on, and yeah, you can see it. It's not too good yet. We'll get there eventually. Anyways, what I wanted to show off is that if I go into here, right, the circles are still there, so there's no depth test. So I'm gonna add that real quick. And there it is. It's fixed. Also, it appears that the alpha blending is somewhat broken. I tried to fix it and it only got worse. So, yeah, screw that. I have a better idea though. My first idea was to just throw away alpha blending altogether and just have an array of a bunch of colors. So this would be a 50% visible object, and then here's like a, let's say, another one like overlaid. I don't know, just got color for random ones. And when I apply the blur effect, you will see uh, kind of, I'm gonna reapply it a bunch of times, and there we go. So that is what the color would be right there. And at first glance, it worked. Let's go. There's no more bugs. But when I pressed F3, I kinda So the thing is, I created an array of 256 different colors. So let's bring it down to, let's say, 64. And yeah, should somewhat improve performance. Oh, okay, it's just broken now. God damn it. So I discovered a flaw in the system. See, when the object in front is being drawn first, it creates, like, say, this pattern. And then the other object only considers the black pixels because it's not gonna overwrite the green ones. So it's gonna insert itself there, and the blur is gonna apply correctly. But what happens when the red is in front of the green object here? Well, since the green is behind the red just says, let's just overwrite it. And the green just kind of disappears. So the change of perspective has decided to use somewhat like a liquid-like system. That right there is the green object. And now the red object is behind. If it's behind, it's gonna write itself here. If it's in front, it's gonna override the green, but the green is gonna then go down here. And it's just gonna work like that. So in my implementation, I actually decided to go for this kind of array. So let's say we put the green in here, let's say green's color to whatever, and left number is 20. So when there's a red object, when it's below, it's gonna insert itself here. When it's in front, it's gonna do this instead. And yeah, turns out I didn't really have to go with the pixelated approach, and with this, I just needed an array of, like, say, 8 of these, and that just worked perfectly fine. Hell yeah. We also somehow managed to retain 60 FPS, so that's pretty cool as well. I have added transformations, so we can now have a white sphere. The problem is that the alpha bending doesn't exactly look right. The problem is that we are doing the alpha calculation inside of raytrace sphere, which is unaware of the transformations that we are applying to it. The solution is to simply return the end position, and then outside the function where we have the transformations, we can calculate the alpha. And now it looks correct. Here is a white translucent box that is just in flush with the blue ground below it. And here is one that is going through the blue ground, and it kind of looks like it cuts through the ground. What you might be expecting is that the only part of this box that gets considered is from here to the ground. But what's actually happening is because each object is checked individually, is it's actually going past that, and that is all of the box it considers, and it puts it into this region, right? So it's as if all of this is in there. And so it's as if all of this was in front of that point on the floor. The solution involves moving the alpha calculation down to the compositing state, so it's no longer done up here. And I'm putting the start and the end depth into the data chunk. Leaving the implementation for later, but you can see that it works now. This box is still going through the ground. I did not separate it into two different chunks. It now works as expected. I can even enable a fog, but you will see this weird issue, but it's still kind of visible. And yeah, the other issue is that the FPS is kind of, yeah. The basic idea is for each segment, before it's applied to the final color, scan ahead to see if there are any segments right ahead that are overlapping. For the actual implementation, in the main compositing loop I put another one, which increments the outer loop since the objects already scanned here shouldn't be at the end there. They should keep the ON complexity on the surface, but yeah, JLSO kinda doesn't work like that, and so this nested loop just causes a slowdown. In fact, shaders are so weird that even modifying the loop variable like this causes a slowdown. After a bit of rearranging the logic, we are back to the 60 FPS region. And interestingly, one part of the incorrect tinting issue has also been fixed. It should be noted that a proper fix for the tinting issue would require a bunch of scanning, which I am not willing to burn the GPU, at least for now. So here is a little thing I put together for the end of the video. I dropped 50 of these circles into this low box and I can just move them around like this. So that's very cool. I can also reset them so they can fly out as well, because they spawn above like that, and these just fly off into the distance. With this, we can also see a practical thing about how this thing is optimized. So right now, you can see a frame is like a 40. It can go much lower if right here it gets to 30 because of a lot of overlap for these circles. If we go up and let a bunch of them fly out like that, suddenly we're at like 50 plus almost 60 FPS. So because there's now a lot of the circles here, that means it's not doing so much work. It is stopping right here where it hits the wall. Because it's completely opaque, it just ignores the fact that there are circles. Actually, they just went out in the distance. But even if they're currently falling down, the renderer completely stops at the point there's something opaque. If I look out, it goes further, and the frame rate is lower than I'm actually looking. There if I'm not. And here is what it would look like if I were to switch to the normal renderer. So you can kind of see how the scene is set up, except the transparent box is actually really weird. Like, I have no idea how that lighting is working right there. Just is, I guess. You can see that if I go here, you can see this. This is the box. This is what you see. So there's no fog whatsoever with the normal renderer. There is some basic lighting. I'm not sure if that's even visible. Maybe if I disable the fog, then it can become somewhat visible. Yeah, you can somewhat see that it does exist. I think I forgot to set the circles to be transparent. I'm so good at this. Okay, these spheres are actually transparent now. And this is what the transparent circles look like normally. You can see that there's some sort of lighting that's missing in the ray traced version. And there's something that I will be adding in the next episode. Some nice lighting. So it looks something more like this. A mix of this and this. I've also been looking into potentially drawing some actual measures in the scene that might just blow the GPU up completely because of that all those triangle intersections. Maybe fun. I can already see how slow it might get. We'll see. Anyways, this is me ray tracing at like a 4040p on the RTX 1050 Ti. You know the best RTX GPU. Yes, and yeah. Thanks for watching. Subscribe if you want to see more. Like, comment, stuff like that.